All right, we're going to go ahead and get started now. I'd like to thank everyone who is joining us today. Welcome to today's CNCF webinar, What Does the Open Source Community Need from CI/CD? I'm Caitlin Barnard, Marketing Manager at CNCF, and I'll be helping to moderate today's webinar. I'd also like to welcome our presenters today, Vivek Ravishankar and Tom Trahan at CircleCI. A few housekeeping items before we get started. During the webinar, you are not able to speak as an attendee, so there is a Q&A box at the bottom of your screen. Please feel free to drop any questions in there as they come up throughout the webinar, and then we'll get to all of those at the end. The session is being recorded and will be sent out afterwards along with the link to the presentation, typically within 24 hours. So with that, I'll hand it over to Vivek and Tom to kick off today's presentation.
Thank you very much, Caitlin. Really appreciate the invitation and happy to be here today. So myself, I handle business development, so everything to do with partnerships at CircleCI, technology partnerships with companies that we integrate with, as well as channel partnerships. And Vivek from our product marketing team is always thinking about the product in terms of the best use cases for our customer base. So that's probably the last time you'll hear us talk about CircleCI today. The rest of it's all going to be about CI/CD, particularly for open source projects. So let's get started. So today we're going to run through a few topics and then finish up with Q&A. And so look forward to your questions here at the end. First thing we're going to talk about is, ultimately why is, continuous integration, CI/CD, why is it important for open source projects? And ultimately, why should you be embracing adding this to your open source project? Secondly, we've recently conducted a set of user research reaching out to all of our open source users and asking them for their feedback on what they're looking for in CI/CD projects, what's important to them, and what the general makeup and profile is across these various projects. And so we're going to share some of that information with you today, which should be really interesting. And then we'll finish up with best practices on what we've seen across the projects that open source projects, when they do get rolling on setting up and effectively using CI and CD on their projects, what are those practices that we've seen employed the most frequently by essentially the projects that are doing it right, quote unquote. So that's where we're going to go today. Definitely accumulate those questions and submit those to Caitlin as we go, and we'll come back to those at the end. So starting off with why is CI important for OSS? I think ultimately there's not a lot of education required anymore on the concept of continuous integration. I think most folks on the call here today and in the community are now well aware of why it's important and how critical it is to effectively being able to run any kind of software project, but particularly those that start to grow in size and grow in the number of contributors. And as you look now at where open source projects are in their growth and usage across the community and across the world, we've moved from a period where 10 years ago, open source software here at the top of the slide represented somewhere between 5 and 10% of the software that any software project across the world, whether a commercial project or an internal project at a company or a personal project, only 5 to 10% of that software was open source software. And so in fact, its impact on a lot of the work that downstream users were having was fairly limited 10 years ago. Fast forward to today, and open source software now represents, by most accounts, close to 70% of the software base that exists across all the different types of projects that are out there, whether it's proprietary software projects, other open source projects, or individual user projects. It has a huge impact on downstream users. And so the ability for an open source project to effectively put in place the mechanisms to deliver quickly and deliver quality code quickly and make sure that everyone has confidence that what's being submitted and rolled out and released as part of that project is effective and is going to work effectively for their downstream needs has just grown exponentially throughout that time frame. So let's go to the next slide here. And obviously then that has its direct corollary, where is if the open source project doesn't have the ability to put out trusted code or can't do so on a regular, frequent basis, then it tends to become just less useful to downstream consumers. And so, all of us who do open source projects, we all do so with the intent to provide useful software that's going to become and make a difference in the world with all those folks who can take advantage of the software. And so clearly, to maximize that impact and to really create the ability for the most number of users to count on our projects, it does require then that we put in the type of thought and effort on setting up the automated testing and really confidence, adding in the confidence layers that allow us to basically roll out new code knowing that it's not going to break and it's going to be backwards compatible and it's going to meet the needs of our user base. Next slide, Vivek. And so when we think about how that plays out in the kind of the value stream of developing software as an open source project, there's really these three major pillars that folks go through when they think about software. There's ultimately the starting point, which is the creation and collaboration around the code itself. And this takes place, obviously within source control systems. I mean, GitHub and Bitbucket and GitLab are those places where, as a community, open source contributors are coming together, collaborating on changes in that distributed environment, in those source code and in those source code systems, and it really does provide for this ability to create the necessary synergies across folks that are contributing. So, as a project starts, when it's just a single user, managing that collaboration, obviously only have to collaborate with yourself, but as you start to add additional contributors, the coordination across those efforts starts to become more complex. So you need to put in place, of course, these types of automated systems that help to manage that contribution and to avoid the conflicts and to resolve the conflicts that inevitably come up as you start to grow the number of folks that are working together on these projects. On the next phase, when you get beyond the creation of code and the collaboration on code, you have that same set of issues that pop up in terms of the testing and deployment of code, right? So think about the middle pillar of software is everything around building out confidence and in that what you've built is ready for prime time. It can be rolled out to users and used confidently. And so everything that we do inside of a project on that testing and deployment piece is all around getting to successively higher levels of confidence, right? Adding in more layers of maturity in terms of our testing and our validations to know that what we do roll out is going to be able to be run in those runtime environments successfully and going to have its maximum impact that we're hoping for when we build out these projects. And one of the real challenges that you find in the testing and deployment pieces, of course, are those things that we went out and wanted to ask the community about to kind of get their feedback. What are those elements that they find the most challenging and the most useful for them when trying to add CI/CD into their open source projects? So with that, I want to turn this over to Vivek and have him take you through some of the research we've recently done and some of the results that we heard back from our user base.
Cool, thanks. So like Tom was saying, we really wanted to understand, how are CircleCI users thinking about CI/CD? Like, what is the value that CI/CD as a whole, whether even if it's not us specifically, what is the value that CI/CD is bringing to them, and how should it actually be working for them to make open source development easier, not more complicated? So just a little bit on the survey methodology. We sent out a survey to about 14,500 of our users. Of those, we got 827 responses. So we actually got like a pretty good response rate just for a survey that you weren't really required to do. So one of the huge things we just wanted to ask is like, is CI/CD actually helpful for these users in the first place? And we definitely got a positive answer on that one. So most of our users said that it would either be almost impossible to maintain their open source project without CI, or it would be very difficult to maintain it without it. You only have a small number of people who are saying that it would be a minor inconvenience, and almost no one saying that it isn't necessary at all. So we can really see that after these projects have started adopting CI, that it's become really integral to their process, and that's because it's providing value. And why is it providing value? Because our users know that, finding time for, putting in putting in your putting in work into open source projects, that's really the hardest part, finding time, and then organizing a community around open source, making sure that everyone who's contributing to your project is on the same page. Then that kind of falls into the two below that as well: maintaining code quality, um, getting a roadmap set up. You make sure that everyone is aligned on those things. And then test writing is up there also. So actually writing those tests that your CI tool is going to maintain, or is you're going to run, excuse me, is also a pretty difficult part of maintaining an open source project. So because of this, what should you really be looking for in a CI solution for your open source project? Um, the first thing is you generally want to go with a SaaS solution, and that's just because managing servers takes time. It's just going to be easier if you can spend your time actually contributing to your open source project rather than running a server on the side to just be testing that project. And that's one of the reasons that solutions like Travis gained so much popularity early on in the open source community, is because they were one of those first providers to offer a really good cloud-based solution for CI. Secondly, fast build times. This one's pretty self-explanatory. You want to be looking for a solution that's going to be building your code as quickly as possible, because less time waiting for those tests to run and your application to build is going to mean more time that you can put into actually delivering more value to the project. Third is easy integrations with the tools that you use already. So there's a lot of other DevOps tools out there, code coverage tools, things like that are also going to make developing open source projects more efficient. And any CI tool that it has easy integrations with those other tools that you're already using is just going to save you in more time, so that you're not trying to figure out how to share data in between those tools. And then the last one is great documentation. Again, this one is also pretty self-explanatory. You don't want to spend a lot of time diving through Stack Overflow for a month figuring out how to set up your CI tool when you should be writing code for your project. So the other thing we learned is that CI is managed by maintainers. So 86% of our users, based on our sample size, were maintainers of an open source project. And then 89% of those actually manage the CI config for the project. So there are very few people who are managing CI config who are not maintainers. And what we learned from that is that CI needs to be really easy for maintainers, but it also needs to be automatic for contributors. So it should be something that maintainers are spending a little bit of time setting up, making sure it's working well for their project, but then it also needs to be delivering value to those contributors who aren't editing the CI configuration, but still need to be benefiting from the building and testing of the project. And so what you should look for this is config as code, because that's going to make it much easier to align everyone who's contributing to the project on what is actually happening within your CI tool. So maintainers who are setting up this config don't have to leave the VCS. They don't have to break their workflow to set up CI. And then everyone else who's just contributing to the project can also see what's happening within the CI system without needing to go to a separate tool to be able to do that. And then kind of going along with that is publicly accessible pipeline status pages, so that those contributors can actually see the status of their jobs without having to go to that other tool. And so most tools like CircleCI that work well for open source are going to have a public build page for any project that is open source, and really any project that is kept public, so that anyone who wants to see the status of the builds for that project can just go and look at it without having to log in or authorize anything like that. Then you also want tight integration with your VCS, because you don't want to spend time mirroring permissions from your VCS over into a CI tool. It's easier if you can just get set up with something that's just going to automatically take all of your user permissions from your VCS that you've already spent time setting up, and move that over into your CI tool without you having to do any more work. And then finally, secrets management is also a huge one. If you're a project that is using any kind of secrets, maybe for deployment, something like that, you want to be able to tightly manage those secrets so that only the users that you trust are going to be able to access them. But you want to be able to do that without restricting all of your contributors from, still being able to contribute to the project. So there's that fine line there of like, we still need a little bit of control, but we want to make sure it's as easy as possible for everyone to keep contributing to our project. And then another thing is that your project is really never too small for CI, and we're seeing that with the people who are in CircleCI. So 64% of our projects or 64% of the users, excuse me, are contributing to projects that only have 1 to 10 users. And then, a little bit in the 11 to 50 user range. And then, we have some of these projects that are really big, over 50 users, up to, over 500. But most of them are in that 1 to 10 range. And they're, gaining value out of using CI, even at that small level. And that's really interesting to see, and we love to see that these projects are adopting CircleCI at the beginning of the process and then scaling it all the way up to these really huge projects with over 500 contributors. And so CI really should be scalable, and you should be thinking about that at the lowest level. When you're starting with 1 to 10, maybe you only have 4 people contributing to your project, but you still want to be thinking about how is your CI going to scale as your project becomes more popular. And it's always easier to implement good CI practices when you're that small, rather than trying to rip out your old system and put in something new once you realize that it's no longer going to be scalable for a large project. So what you should look for here is powerful orchestration capabilities. So, those tools that are going to make it really easy to still make a powerful testing framework when you grow from, that 2 users up until, 100 contributors. And then another thing is the declarative syntax. And that's just because it's going to be a lot easier for new contributors to the project to see what's going on in your CI tool if you have a declarative syntax. It's a lot easier to get lost in complicated scripting than it is to get lost in something like YAML, where it might be long, but you can still just go through and read, and you can pretty much understand what's going on there pretty easily. And then the last thing that's really nice to have is any type of reusable configuration. So as you start having more jobs, and maybe you even have like side projects that are connecting to that original project, it's really nice to have config that you aren't going to have to manually copy and paste anywhere. So anything that you can use to parameterize your configuration so that you can just import it into your config, and then you can use the jobs or commands that are in there in multiple times in a single project, or many times across many different projects. Cool. So going after that, we're just now we're going to talk about what are some best practices. So now that you have hopefully found a CI solution that you think is going to check all of these previous boxes and is going to work well for your project, how should you actually think about setting up that CI tool? And I'm going to hand this back over to Tom so we can talk about some of those best practices.
Thank you, Vivek. And so, best practice number 1 that we've seen is you've got decisions you can make around whether to build every single commit for your project or whether to build only pull requests. And a lot of times, this really does come down to decisions that you make in terms of how frequently you want the testing to occur, and how, I guess, how aggressive you'd like to be on validating every change that comes into the system. So what we see across a lot of open source projects is that folks do configure these to only run on pull requests, and so that there might be testing running on forks or other areas on every single commit, but the project's configuration for testing and for continuous integration are generally often set up to only run on pull requests, and so that only when contributions have reached the stage where they're ready to be considered by the broader community, are the test suites being executed, in full. This is, obviously this is a trade-off decision, because you get a lot of value on testing on every commit as well. But this is one of those areas that there becomes a tipping point in the growth and the size of a project where that decision may become a necessary a change for the project to make. Whereas a lot of folks, what we see is they start out with running their configuration and their testing on all commits, but as the community starts to grow, the number of contributors and contributions commits grows, they hit a point where they realize that it's more effective for the for the entire community to run these only on pull requests. So that's one of the things that we've seen. The second thing that we've seen come up, pretty much on every single project is how you manage secrets, and clearly having an intentional approach to managing secrets carefully becomes important in any kind of community, because you want to make sure that any secrets that are providing access to environments or other elements, are properly controlled. And so when it's a small number of maintainers with no external contributors, that becomes a fairly straightforward process to manage. But as soon as you start to add on external contributors who are not named maintainers on the project, but are there contributing pull requests against the project and are part of the growing community, at that point, being able to determine whether or not you want everyone to be able to take advantage of certain secrets, or you want to restrict access to those secrets, becomes an important consideration. And so, again, this is one of those areas that as a project starts to scale and grow in size, and depending on what exactly is happening as part of the CI/CD pipelines, if they're performing testing but not deployments, often this is not such a high priority. But if they're performing deployments out into integrated test environments, for instance, then this becomes a growing, it grows in importance. It becomes an important element for the projects. And at that point, typically what project maintainers will want to do is restrict access to certain secrets and environment variables to only a particular set of users, oftentimes the named maintainers on the project, and only they are able to get access to certain variables or secrets that would allow certain actions to take place. The next one that we've seen used pretty frequently and effectively by open source projects is to use condition-based testing. So ultimately, instead of on every commit or every pull request running an entire full suite of tests, they'll often decide to use conditions of a particular commit or a pull request to determine what elements to run and what elements to test for. And this provides a lot of control over the length of tests, the resources being consumed, and ultimately the actions that are being performed along the way. And so, there are many different ways that conditions can be set up. Probably the most common one would be based on branch. And so whether or not it's a feature-based branch or whether it's a commit to master, often involves a different set of testing and activities to be performed. And that's probably the most common condition-based testing that we see. We also see differences being used on whether it's a commit or whether it's a pull request. Also, one that's a real common one that folks use on open source projects is evaluating what changed from a previous commit to this commit and deciding what to execute. And then lastly, we've even seen ones where folks are using the person who triggered a pipeline to determine what sort of things to perform there as well. The next one we've seen related to condition-based testing is really tiered testing. And this really is around setting up pipelines of tests that will start with fairly innocuous tests and fairly, I would say, inexpensive and quick tests to run early in the process, and only proceed to larger, more expensive or more time-consuming tests later in the flow. And so a common one that we've seen here be executed, a project that I'd been involved with in the past had 13,000 unit tests. And so on every single commit, before going down the path of executing 13,000 unit tests, there were some basic housekeeping that was desired to be in place before going through all that more expensive processing. And so providing a first step in a pipeline to perform linting checks or to evaluate commit messages and make sure that they meet up with standards that you set up for your project, really to create the hygiene elements up front in the process, and only proceed to the more advanced testing after passing those initial tests, becomes a really nice best practice that we've seen people execute. And so in that particular project, when that one first started out, and as the test cases started to grow substantially, they were being executed on every single commit. And it was only later realizing that we'd get through this entire set of testing only to realize, wow, we still need to go back and make changes now because there's elements about the syntax in the code that doesn't work. Even though it passed all the tests, it doesn't meet our policies for how the code should be constructed. And now we're going and restarting that whole process again. And so that one tends to be a really nice one for folks that are getting to that scale where they're already thinking about the structure of their code. They're thinking about the hygiene of that, particularly as more and more members of the community start contributing to it. The next one that we've seen here is, enabling the ability to run testing on forked repositories, or to build pull requests that have come from forked repositories. One of the nice things about that is that you could actually, as you start to scale, you can actually employ a forked strategy where contributors are essentially requested to fork the project and be developing on their local accounts or their own accounts first before issuing pull requests back into the project that will now execute tests for the whole community to see. And so they can be essentially working on their own changes, testing their changes within their own accounts based on all the same configurations that exist on the open source project itself at that master branch layer. And so the ability to do that and essentially have users have the freedom to be testing and committing frequently before they come back to the community and issue those changes back to the community, has been a practice that we've seen folks use pretty frequently as well. Obviously, there you've got choices to make between a branching strategy with feature branches, with all development and all testing taking place inside the account of the open source project, or splitting out and doing the forked approach. But we've seen both of those strategies be used effectively. And then the last one that we've seen is ultimately around caching. So, one of the elements about testing, particularly as you start to really build up the maturity of the testing that's being performed. As I mentioned, that project that had gotten up to 13,000 unit tests, all of a sudden, the length of time that it takes to execute tests becomes quite important. And so there are a variety of strategies that can be employed on a CI/CD system that will help you really focus on bringing down those times and those durations. And with the more contributors and the more contributions happening simultaneously, the more important these become, because generally speaking, we're avoiding queues and waiting in queue lines for your builds to run ultimately becomes a priority for any team that starts to grow in size. And caching is one of those elements and one of those features that in a CI/CD system can be used to great effect, because it can really, when you look at any CI/CD automation, oftentimes two of the most time-consuming elements on any particular run are going to be the downloading and installation of dependencies from external sources, like an npm registry on the internet, or Docker Hub, for instance, or it will be the execution of tests. And so employing strategies to smartly and effectively bring down those build times becomes really helpful to the community. So caching is one of those great ones because it can avoid that first category of continually going out and re-downloading open source dependencies or other pieces that have not changed since the last time that builds have run. And as long as we're here talking about caching in that second category of tests themselves, the ability to split up and run tests in parallel becomes another effective strategy for drastically reducing build times as well. For instance, I mentioned that project with 13,000 unit tests. That one, I think, in the end, ended up parallelizing tests across 20 different parallel processes to really shrink the testing time by to make it 1/20th of what it was before when running on a single node, for instance. So those are 6 practices that we've seen open source projects, effectively put to use, and some of which have a little bit of a view to the future when they start to see that they're scaling at a pace where they're going to get many contributors participating in their project and in their community simultaneously. With that, that's where we're going to end today's presentation, but throw it open for questions. So we would love to answer any that you have, and we'll do that now. So Caitlin, I'm not sure if any questions have come in during the presentation, but we'll turn it over to you to administer.
Awesome. Thank you both for the great presentation. So as Tom said, we have some time for questions now. So if you have any, please drop them in the Q&A tab at the bottom of your screen, and we'll get to as many as we can.
I guess while we're waiting, one of the common questions I've received is, how do I actually know what I'm going to need when I start scaling to a larger project? Because if you've never worked on a huge open source project and you've never run CI for a big open source project, you've never really experienced what you are going to need to be able to do with CI at that point. So one of the suggestions I would have if you're in that situation is try to find some open source projects that are already pretty big, that are out there, that are somewhat similar in type to the one that you are building, and see what their CI configuration looks like. See what tool they're using, see what they have set up, because that could be a good indicator of what you may need down the road once you start growing. Okay.
Excellent. It looks like we did get also a couple questions come in here from Nick. When it comes to infrastructure as code versus just your application code, do you see differences in how you look at CI or CD? Notably, with Terraform, Kubernetes, Istio, you are able to create load balancers, clusters, services, and even routing rules as YAML. Do things change between these lines of code versus application logic? Great question. What we see has become an increasingly common use case on CI/CD is the validation of changes to infrastructure as code, right? So for all those mentions you meant, Terraform scripts, deployment YAMLs, etc. All of these elements ultimately, just X as code, anything as code, can inevitably be tested for the changes that are being applied to them. And so we see one of the really popular elements are to start fairly simply, which is any change to those elements, to essentially run those in their CI/CD system and test them out before executing them against a particular environment, just to make sure that they see the execution of that instruction looks well formed and is going to execute properly. The other thing we're starting to see is a lot of third-party tools that allow for policy management on those types of configurations as well, so that an organization can set up defined policies about what can and cannot be changed in their infrastructure as code configurations. And so those policies can then be validated against changes to those files as part of the CI/CD process. So before executing a far-reaching change, for instance, into a production environment that might hit 5,000 servers, those changes can first be validated against policies that have been configured and essentially defined by the organization. So we're seeing that to become a really nice way to add this level of maturity into managing the infrastructure as code. And then the last element of it, when you think about infrastructure as code, and you think about, for instance, something like Terraform, one of the real challenges, in any of those configuration systems is the ability to get multiple people able to work with the same set of configurations and essentially the state of where those elements are. And so enabling those for centralized use and coordinating those through something like a CI/CD system does become a priority for folks as soon as you start to move beyond just having one or two people manage that infrastructure via those configuration files. And so to summarize that long answer, do things change between these lines of code versus application logic? And the answer is really they don't. All of it is code. All of it can be tested for what you expect to be changed and implemented and how you expect it to work. And there seems to be a lot of great new third-party tools coming out that allow you to validate those changes as part of your CI/CD. Next question from Harish, what's the best stage to do performance testing? And so this is one that, there's differing opinions on here. The one that we've seen probably the most frequently is it does come later in the pipeline flow because ultimately here you're trying to get to a point where, you validated and you've got code that you're now pretty sure you want to put into production. And now you want to make sure that that last set of problems that might occur, which are ones you don't see until you test it at scale, aren't going to show up in production, right? Because you can test, unit testing, you can do integration testing, you can do all sorts of different validations along the way. But a lot of times, some of your problems just won't show up until you have lots of users hitting the product at scale. And so we typically see that coming as the last stage in a pipeline, or as we think of like a pipeline of pipelines, where you might run a pipeline of various tests first, and concluding with perhaps a deployment out to an environment that you can now test at scale, whether it's your QA environment or whether you've created a replicated environment of your production environment. Again, like I had mentioned before, there's a lot of great third-party tools now that make that type of replication doable within your CI/CD systems. But it usually comes at the end, and it comes at the point, because it generally doesn't involve a significant testing load as well. It's one that you want to make sure you're ready, and it's the last stage before production. And so that's typically where we see it come up, and folks will make sure they've done all the other validations. They know this is a piece of functionality that they're ready to put in front of customers. Now they want to make that last test and prove out that it's not going to break at scale. So. All right, if there's any other questions, throw those out into the Q&A tab at the bottom of the screen. Otherwise, we'll wrap things up here shortly. Okay, here comes another one. Thoughts on the cloud delivery framework, and notably CI's position or just overall thoughts? Foundation, that's what I thought you meant there. So the continuous delivery foundation, which is a new foundation, much like the CNCF that has recently launched. It launched in March at the Open Source Leadership Summit, and has an initial set of 4 projects that are now part of the foundation and are coming together with the first set of meetings, and the community is starting to build on top of that. So the CDF looks like it should be a very useful mechanism, a lot like CNCF, to coordinate around standards and particularly standards for interfaces between the different tools and tooling that exists for continuous delivery CI/CD. If you think back to that earlier slide where we were talking about how there's really these 3 major pillars that exist when you do software, right? There's the creation and collaboration around code. There's everything that you do around validation, building and testing and delivering that software to users. And then there's the runtime environments where software is run in a production environment and has to be monitored and properly attended to in that runtime environment. And so when you look between those 3 pillars, there's interfaces between those 3 pillars that the greater we've got standardization around how you can communicate across those pillars, the better off everybody is going to be, because then you can plug and play different tools and different strategies easier. The second thing is that when you look within that middle pillar for what happens within CI/CD, there's many different tools that we mentioned that get brought to play inside your CI/CD processes. So when you think about all the different tools in your particular tool chain, and if you were to ask somebody else on this, you know, if we were to throw it out to all the participants on this call and say, hey, everyone put your tool chain out into the Q&A session right here, we're likely going to get 24 different tool chains. And so it really does call out the importance that the ability to integrate and interface between tools in the CDF becomes really important as well. And so we really do see the CDF providing a great function there in defining those standards. And the second thing is just the separating it out as its own foundation, as opposed to making it part of the CNCF, really does call out the importance of that middle pillar, of how important it is that as a community in the software world, we all get to a higher and higher level of maturity in our ability to build out and test and validate the value that we're putting in front of customers. All right, so now we have a question from Anthony here. What are the triggers you see that cause teams to move from an imperative model of pipeline configuration like full programming languages to more declarative models like YAML? Any pitfalls or things to be aware of when making this transition? Yeah, great question, actually. One of the reasons you move to something like YAML, ultimately a declarative model, is to simplify, right? To make it so that it's easier, it's more easily understood, so it can be transitioned across team members. It's also easier to set up the first time. Now, one of the pitfalls to a declarative model is that it only works, of course, for use cases that are covered by the declaration. So if you've declared something that's covered by that's configured to perform a certain way behind the scenes based on that declaration, then everything is great. But as soon as you want to perform something that gets very imperative, where you want tremendous control over what it actually occurs, and it goes beyond what the declarative use cases are supporting, then of course, you want the capabilities to go to an imperative model. And so what we always see here at Circle, and what we see across, you know, to be the model that no matter what anybody says, you know, in a public statement, in the end, what we always see is people want it to be simple until they don't. They want it to be simple and easy to do for the most common use cases, but as soon as there's a specific need where they need total control, people want that total control. So ultimately, we always believe that the best model is one that brings those two worlds together, that allows you to be declarative for the most common actions and use cases. So things that you're going to perform exactly the same way that someone else is going to perform, those things don't need to be defined imperatively every single time. Those can be done declaratively, preferably through reuse of that declarative configuration. But as soon as you have specific items that are applicable to your project, you want that ability to go and do imperative activities. And so ultimately in your CI/CD system, you're going to want to look for one that lets you do both. And I think that's you know, a really important detail that sometimes isn't thought of, you know, up front when deciding on where to go. But in the end, that's the one we see over and over again come to light. So, all right. Well, I think, Caitlin, that's the last question that we've got out there from the audience. And so unless there's any more, thanks everyone for joining us today. We really appreciate it. And if you have any other questions after the fact, please feel free to reach out to myself or Vivek as well. And we'd be happy to engage on that.
Awesome. Thank you both so much for the great presentation. And thank you to everybody who joined us today. The webinar recording and slides will be online later today. And we're looking forward to seeing you at a future CNCF webinar. Thanks, everyone.